Yeah, so I actually had this presentation all created about a week or two ago. And the first half was strong, the second half was weak. I didn't want a Game of Thrones moment where my second half is weak and I lose everyone. So I was thinking about how would I redo this. And I went to a conference last week, Lead Dev, and one of the feedback that I kept hearing about other presentations is that there's no like lessons, things to take home for you. So instead of just telling you about my tale with ClickHouse, I wanted to give you something that you could take home with you. So my first idea was, let's not say ClickHouse at Attentive. I would say, so you want to be a big data superstar, live large, a big house, 5 cars, you're in charge. However, I realized that most of you probably don't know Cypress Hill and you listen to like Ice Spice and you have no good sense of music and you're insane in the membrane. So I'm going to skip that one. And instead, I'm going to give you a guide to building and migrating big data systems and anecdotal tale with ClickHouse at Attentive. So some background about myself and my company. Also, there's going to be a lot of cat pictures. As you can tell, I like cats, so just be prepared for that. I'm Larry. Hello. I'm a principal engineer at Attentive. I work on the targeting team. Before that, I was a staff engineer at ActionIQ, and before that, I was at Nexus. I like cats, whiskey, going to the gym, solving problems, and cooking with my toddler daughter. Unfortunately, these don't really overlap. You can't really do like these different things at the same time. Whiskey and the gym, and whiskey and what's that? And salad. Yes, yes. Salads and your daughter's okay, but whiskey and your daughter can get a little dicey. Yes, and salad. Yes, and cats don't like whiskey. They do not. I have. They don't like the smell. I did not force feed a cat whiskey. So what is Attentive, where I work? We are an AI, what we call it, this is our byline, is that we're an AI-powered SMS and email marketing platform. What that means is we send millions, billions, I don't know, trillions of messages on behalf of our clients to their customers. And we leverage our clients' data to send the right message to the right customers at the right time. So you're like, okay, marketing technology, what does that mean? Do we do this? No, we do not send you spam messages about a USPS package that you haven't claimed and you have to enter in your credit card. And we do not tell you about voting for people. We are not your friend Donnie. What we are is we send you coupons. So if you've ever went to a site and it's like, give me your phone number and you'll get a coupon for 20% off, you'll give the phone number and you'll get 20% off and you'll be happy. Or we'll tell you, hey, that shoe that you were looking at that was out of stock is now in stock. Go buy it. Or hey, that order that you made, it's now delivered. Now you might say like, oh, marketing is annoying. I don't care about coupons. Well, maybe you're one of those people on Blind that works at the big G, makes 700,000 total comp each year, doesn't need coupons. A lot of us do need coupons. Some of us need multiple jobs. Some of us are getting too old to dance at Chippendales. I digress. This is what we do. We make actual marketing messages and emails and texts relevant for you and things you're going to actually want to click on. I work at the targeting team at our company. And like I said, we're trying to send the right messages to the right customers. And that's what targeting does. We try to figure out who are the right customers for your messages. And to do this, we ingest a lot of data from our customers about from our clients about their customers. None of this is like interesting data. It's all just kind of like marketing data. So don't be like worried that we're like a big brother. We're basically knowing, that you like shoes, or that you live in New York, or that your favorite color is blue. Stuff that's like useful for marketing, so that our customers can actually send messages to people that care about them. So our current system that does targeting, it's evolved over the years. And since it's evolved over the years, and it works fine, but it's spread over many databases. As you work with technology and microservices, you spool up a new service, you spool up a new database. All of a sudden, you have like 9 or 10 databases powering your system. I joined this project and this team this year. Before that, I was working on sending infrastructure. So you want to build or migrate a big data system. It's kind of what the talk's about. Step 1, why would you want to do this? Well, it's a cool resume project. Maybe that's your answer. It's probably not the best idea, but these are hard times. You might want something good on your job resume. I would not recommend partaking in a project like this for that. You might actually need to build some system, and you might need to build a big data system. So before you actually go on this, you should figure out why. You should understand the problems that you're trying to solve. This is very important because you need to understand your problems in order to solve them correctly. Sometimes we just have some vague notion of a problem, like, the thing's slow. So we're like, oh, let's use this technology, it'll make it faster. But if you don't actually understand the problem you're trying to solve, you probably aren't going to solve it correctly. You also have to understand your data and the size of the data and the shape of the data. I've heard stories where people are like, I use Spark for computing, distributed systems, blah, blah, blah. And then you say, okay, how much data do you have? And they say, oh, about 200 megabytes. And you're like, well, 200 megabytes could fit on my phone. So why are you using distributed systems? Why are you using this complex thing, et cetera? So, undertake a big data system migration if you actually have big data. And also, you should have a good measurement system, good observability, so that you understand where things are bad and where you want to be. Because if you don't have that up front, you're not going to know if things are actually bad, and you're not going to know if you're going to succeed. So at Attentive, we're undertaking this migration. Why did we want to do this? Well, we want to keep growing, keep getting more clients, keep getting more customers, all that, more data. And now in the 2024 plus years, everything's about ML. Whether you believe it or not, there's a lot of data. In order to power ML, you need more data, and then ML produces more data. So now it's just like data is growing way faster than it used to grow. We want to be smarter, faster, and simpler. Our system has been growing over many years. We want to simplify the system, make it easier to build product on top of, make it faster, all the good stuff. Kind of answer there is like, we have 9 databases, let's move to 1 database. Kind of like a little bit obvious, but like seems like the industry always goes in circles on this. But for us, moving everything to 1 database would really simplify things and allow us to make our system more performant, scalable, et cetera. Okay, cool. You've decided you need to do this big data system, big data migration. How do you choose a database? There's a lot of things you have to take into account. You actually have to understand, as I mentioned before, your data and your query patterns. This is important because each big data system kind of excels at a different thing. And some of them excel at a lot of things, like ClickHouse, and some of them excel at not so many things. So if your data lookup is always key-based, like you should use a key value store. But if you need to do queries, you can't use a key value store because that's not going to be optimized. So you have to actually understand, your data and like the actual patterns you're going to be doing so that you could choose the correct technology. And what you want to do is you kind of want to research your different options. Here, you might actually become like a local expert in these options. You don't want to get too deep, but you want to actually understand what you're talking about. And you actually want to understand the different options that you're looking at. And to find options, you could go to the industry, see what your competitors are using, what other companies are using. Because if other companies are using it, might scale and might fit your need. You should talk to your friends, what they're using at their companies. You should go to tech talks like this, and you could learn more about ClickHouse and other technologies. And then think about ubiquity. Not just because a database is commonly used doesn't mean it's good. But if it's used a lot, it probably means that it's stable or somewhat good. Like you shouldn't just find a Apache project that came out last week and be like, well, okay, I'm going to build my company off of this and risk a lot. If other people have tried and tested it, it might have some legs to it. Another big thing is don't be emotional. Sometimes we kind of like favor a solution and then we don't look at the data and we're just like, I want to do that solution. I want to use that technology. You should try not to do that. And when I said be an expert, you also don't want to spend too long investigating technologies. You can't spend 5 years figuring out which technology to use because then, management's going to fire you. You also have to understand your company. Each company is different. Each company has different amount of cash in the bank for things they want to spend on, or they might have different technologies that are already in use. And maybe using one of those technologies is good. Maybe it doesn't fit your need. You have to understand your company and what they do. And then you're going to understand people that are going to be naysayers in whatever you choose, because someone's going to detract no matter what. And they'll say, well, did you think about, BananaDB? And you're going to be like, okay. So understanding your company, understand what they're using is very important. Also, as I mentioned before, understanding the cost. We're not in ZERP time anymore, which is an odd acronym, but things cost money now, and we just can't just print money. So you want to kind of keep things cheap or as cheap as possible. And also understand your real constraints and your artificial constraints. So product might come to you and say, I want result sets within nanoseconds. And you're like, for what? And then you keep poking them and they're like, oh, well, actually it's within like 30 seconds. And you're like, oh, okay. Well, That's the real thing is 30 seconds. The artificial one is as fast as humanly possible. At Attentive, what do we do? As I mentioned, we wanted a single database to solve hopefully all our problems, but at least most of our use cases for targeting. We wanted something fast. These are our systems online. It's not like reports that generate an email to you. We want fast systems that can be somewhat interactive. We want to handle a load of data. We want to be able to export a load of data. So when you're trying to build a campaign to send to people a coupon, we have to extract all these user IDs that match your criteria. And that could be millions of user IDs, which is a different use case than a lot of databases where they can aggregate very quickly, but not return you large result sets. And actually, some very popular databases fail at this in very interesting ways, but I'm not going to poo-poo on anyone. For our use case, we also want to support idempotent mutating data. So if you think about some examples I gave and you want to target a campaign, you might want to target someone that's in New York, but what if they're on vacation in France? Do you want them receiving a text message at whatever weird time it ends up being in France, like late at night or early in the morning? Or do you even want to target them if they move there? So we wanted to be able to have data that changes. And also we wanted it idempotent so that if we need to replay changes, we get the same result no matter what. A lot of databases, big data databases are kind of not mutable. They want you to set something and then that's the end result. But for us, we kind of have some changing data. And as I mentioned before, like we didn't want to break the bank. There's this concept of things that are embarrassingly parallelizable, but that could also be embarrassingly expensive. So sure, you could spool up like 90,000 nodes of, I don't know, Trino or whatever. I don't want to poo-poo Trino, but that could cost a lot of money. And sure, it'll be fast, but is the juice worth the squeeze? And for us, we want to make money. So someday, allegedly, we'll go public, but who knows? So ClickHouse, first impressions. Sorry if I'm being a little cheeky here. I had never used it before. The name sounds kind of silly just from a first impression. I didn't know what it meant. I was like, is it reliable? I don't know. Is it real? Like you see all these Node.js projects that some kid wrote in their basement and you start using it and it crashes your system. I didn't want a database like that. And all I had was a friend that mentioned it at once. And he's at Ramp. And I just was like, that's interesting. But then I actually spent time looking into it and trying to become an expert. And it was super easy to install. That was the first thing I noticed. When you try to install some of these JVM-based systems, they come with 30 different applications. You got Zookeeper, you got a broker, you got the kitchen sink required. You have to have like Docker Compose just for this one little database. ClickHouse was like super easy to install. It was confoundingly fast. I loaded data into it really quickly, which I didn't even pay attention to that. But then I queried it and I was like, whoa, it can't be this fast. Like, is it caching something? Am I missing something? Is my laptop on like steroids? This is not true. This used to be one of those old Intel Apple laptops. So every time I ran things, like it sounded like an airplane was taking off. But somehow it was like super fast. It supports JSON parsing. So some of our data we get is unstructured. So I need to be able to parse JSON on the fly. It supports materialized columns and tables, which is really cool for us because then we can kind of make different views into what we're doing based on like our query types. And the replacing merge tree is great for what we want to do. This is the idempotent changing data. So for us, we have timestamps for every data change event, basically. And we're just like, okay, well, give us the most recent one. And that's the one we care about. And now we can replay data over and over again, out of order, in order. It doesn't matter. At the end, we get the right result, which is great. It also does like really cool compression, so your storage costs are not crazy. It has Iceberg and S3 integrations. As everyone in the world now, we want to use Iceberg more. I think Iceberg sold for like $10 trillion. So like it's the new hotness. But seriously, like we have some data in our data lake that is just huge data that we don't really want moving around. And being able to integrate was great. Also, as I mentioned, installing is easy, but so is local with Docker. So if you're writing integration tests, you just like throw in an easy Docker image into your code base, and now your integration tests spool up super easy. We had that built for a POC in like a day, and that also Circle CI, we're able to pull in ClickHouse, very simple stuff. So really cool impressions. Cool. Okay. So you've kind of looked at different databases. You kind of have some ideas. Now you actually have to choose a database. So you should judge. Let's have some sort of fair judging. It's important to test use cases that actually represent your problem and your data set. Often you'll hear, oh, this system's so fast. And then you look at what they did to test it. And it's like, oh, you did like the easiest query that would be fast on, like SQLite. Like this isn't like something to prove that the system is actually going to scale and is fast for our use case. So you want to actually test with data that matches your use case and queries that match your use case. You want to be fair, of course. I said, try not to be emotional. We're humans. We have those unconscious biases, but like try to be as fair as possible. Try to be equal. Try to give each technology a chance. And of course, create measurements for your use case. Certain things might be more important than others. Like if your company is bootstrapped, cost might be super important. But if you're just printing money, cost might not be as important. So come up with some measurements and then figure out the weights of them so that you can actually make an educated decision. Take good notes as you're doing this judging. Use your metrics. We use Datadog at work. We could just create easy dashboards and be able to compare it easily. And then at the end, come up with a simple comparison chart where anyone in leadership, anyone in your company could just look and be like, well, that's the clear winner. So for us, we did this pretty much, we did two paths. We did replaying production traffic, and we also created a data set of mock data to represent our real data set. Replaying prod traffic, it can be tough to do at companies, so not everyone can do this. But for us, we had some like capturing tools, and we were able to replay streams of data. And we use that to kind of load test inserting data, see how quickly our different data systems can insert. And then our fake data was more used for our query patterns. And this allows us to very evenly compare the results from different systems because it's the same exact data set once it's in the database. And we would use this fake data for inserting performance, retrieving, updating, etc. So for us, ClickHouse is the winner. For our use case, it's the fastest. There's always like these debates about like, oh, this might have like edged out in this cache thing. But for us, it was like at least one of the fastest. Idempotent mutating data, as I mentioned, super important for us. When you start looking under the hood of some of the larger database systems, they can mutate data, but they don't say how. And then you look into it and they're like, oh, we are going to lock the micro partition while we update the data. And you're like, lock? That sounds scary. I don't like that. So you want to be able to mutate your data, at least we want to be able to mutate our data quickly and not have weird side effects. There's the cloud offering. I don't run infrastructure anymore. You might enjoy running databases, but once you run something yourself, you become that expert. And when something happens, people call you at 3 a.m. I used to get called about RabbitMQ because I installed it once. I don't know anything about Erlang, Nisia, whatever the hell it's called, but that's what kind of happens. For our use case, I didn't want to run it myself, and there's a cloud offering. It has Iceberg support, and it's getting better. It's a nice initial offering for us. The materialized views and columns are great for us. So we could have unstructured data that we try to coerce to different data types. So everything can be a string, of course, but then we're like, maybe it's a number or maybe it's a date. So we could have materialized columns for that. And again, the easy local running is great. We want to be able to run tests and not have to connect to external systems like a cloud product. So here we could just run ClickHouse internally and be able to do all our development and testing. In theory, you could test and write your code on an airplane in airplane mode, but I don't think that actually works with Gradle, but that's a different story. Cool. So you've chosen your database. You're happy. Maybe people are happy with you. Now you actually have to create the infrastructure. Well, for us, we use ClickHouse.cloud. Now I'm just selling ClickHouse, but with ClickHouse.cloud, you kind of just like, this is from their website. This isn't our data thing, but it's very quick. You just sign up. You click a few buttons and you have your database, you have your endpoints, etc. Super easy. You might want to run it yourself. I don't hold any qualms with that. That's on you. I didn't want to. ClickHouse.cloud was awesome for us. Okay, so now you have your infrastructure. Now you want to create your schemas and write data. Getting data into your database is important. The next few slides are going to be ClickHouse specific. For ClickHouse, schema design is super important. So it turns out under the hood, and some other people will probably give you more technical details about this, the crazy performance is generally based on the sort key. Your data is sorted under the hood in these partitions, and that makes it super easy to find the data if you're querying based on your sort key fields. That's great for us because most of our queries follow a similar structure. One thing we learned is that you cannot change your sort key easily. So like think it through. We didn't think it through because whatever. And we didn't really realize that our column that we use to figure out the most recent item is a timestamp. We didn't think we would need microseconds for that because why would someone change their location within microseconds? But of course, sometimes that happens with like data being delayed or your external integrations. So we had to make some changes. So date 64 precision was important. Date time 64 precision was important for us. We had to rebuild our table and do the exchange operation, which like swaps table atomically. Not super fun, but these are lessons that hopefully I've learned that you can like skip over. And also materialized columns and tables are super cool. You can do a lot of super powerful things with them. Okay, so now we had to load data. There's a number of existing connectors. Unfortunately, there's no Pulsar connector. I can't tell you why we use Pulsar, but it's kind of a newer streaming technology. No one really has integrations for it yet, so we had to write it ourselves. And we just used JDBC and bulk insert. It wasn't really that hard to write. We have like all the libraries internally, and with ClickHouse, bulk is better. So try to bulk insert as much as you can. And since we're processing our own streams, we had to write, dead letter queue posting in case we don't process the data correctly and be able to replay. But since we're using the replacing merge tree, we can replay over and over again. And that's fine. We don't have to worry because it's idempotent. Our timestamps are always correct. So we'll just get the correct data over and over again as we have to replay. Cool. So now you have data in your big database. So now you have to migrate to your big database, which means you actually have to query from your big database. We're migrating. Some people are starting from scratch. I think scratch is probably easier. You just kind of create some new services, a UI, and then boom, you're done. No one has any expectations. You create your own expectations, I guess. But that's not what we're doing. We're migrating. So migrating is probably harder. So, when you migrate, you just like connect some things and you use some gum and then like you're done. And you have this like ball of garbage here. No, that's not what we did. We actually wanted to do things the right way. So how did we build this? Well, we built a parallel system to our current existing system, which means parallel services. And we wanted to be able to kind of run these things in parallel and compare and contrast. So there's this pattern called the strangler fig. Maybe you've heard of it, maybe not. Basically, if you have old system and new system, you don't want to just cut over everything at once. You want to like kind of pull pieces off. So you're going to say, okay, I'm going to migrate this piece, maybe you'll use feature flags. Maybe you'll say only for a certain subset of customers. And this allows you to build confidence, not do like whole giant migrations. And then like everyone's happy because you're doing things constantly and you're showing constant output. But with big data, this is kind of hard because now your data lives in two places. So you're like, oh, this data set's over here and this data set's in ClickHouse. Like, how do I kind of like merge that together? Which can be a pain, but it was still worth it because it allows us to constantly make improvements and constantly show output. Shadow testing. So if you are doing a migration and you have these two systems in parallel, shadow testing is great. Luckily, we already had a shadow testing framework. But what this allowed us to do was basically we got queries on our gRPC endpoints, and we just replay them against the new system. And then we just look at the outputs, and we compare them, and we compare latency. And this can all be automated. So this helped us a lot. If you can, I recommend it. But it's a little bit of a lift if you don't have that already in your system. Cool, mission accomplished. It's Miller time. No, wait, it didn't go like super easy. As I mentioned, like the strangler fig, when you're moving like piece by piece, big data, that's kind of tough because big data is big. So it's not so easy to just like have data living in two different places for different data sets. Data still moves at the speed of light at the fastest. So there's certain kind of constraints you have to do when you're dealing with two separate systems at the same time. Also, when you have a legacy system, there might be like crazy logic and optimizations in there that no one remembers. So now you have to copy over those crazy optimizations and logic so that your new system matches your old system. And sometimes the crazy logic could be wrong. But if you're fixing crazy logic, your data now looks like it's different. and that's actually not good. So you kind of have to copy over the wrong functionality so that your data looks the same and it doesn't break, the UI or anything. And then you could fix it later, maybe. But now you have like a new system, and of course there's new problems, but that's kind of just life. And as you're doing this, like, it's not going to go so easily, of course. You just have to keep iterating and comparing. Metrics and distributed tracing are your friends, so you could find out where problems are. Make it easy to compare both systems, as I mentioned before. And then you solve one problem at a time. There's a few quotes about this. My former job, someone always talked about, there's only one way to eat an elephant, one bite at a time. I guess people like to eat elephants. I like the second quote better from The Martian. You can either accept problems or you can get to work. You just begin, do the math, solve one problem at a time. So as you're doing this migration, it's not going to work. You find the problem, you fix it. Okay, there's another problem, you fix that. And then you just keep fixing the problems until there's no more problems. And then your system's ready to go live. So I also want to include some random ClickHouse lessons just to make it like super ClickHouse-y. Even though I've given you some interesting stuff, it's been more general to that big data. As you're doing your ClickHouse migrations, you're going to come across some queries that might not be performant. And you're like, well, what if I use something else to make it more performant? Well, you should test it. And you should test it with a lot of data. Skip indexes are one of those things that might help you, might not. And materialized views and projections might help you, might not. Just create them, test them out, run your queries. There's a query explainer, and that will give you information about if it actually helped. For us, another interesting thing that we didn't realize is that data types tend to not have nulls if you say they're not nullable. So if you're trying to like compare some data and understand some things and you do a left join, typically in a left join, if the data on the right side isn't there, you have a null. But in ClickHouse, it'll be the default value. Just know that. But then like integration tests are super important. So write your integration tests and then you'll know these things happen. Also, just like a little jokey thing, icebergs don't move fast. You're using a data lake, it's not going to be fast. So that's why you should put data in ClickHouse, because that's meant for speed. Your data lake is meant for like, I don't know, slowly drifting along.